So guys, again, the papers that I gave you are not your class notes, they're homework. But while you're at this, let me sort of whisper in your ear. For those of you that have become dependent on my screencasts, have I told you what happened to me? My YouTube channel got shut down for copyright violations. So I didn't know this, but when go ahead if you need to. What's that? Yeah. Oh, did I already tell you about the chicken dance thing? Oh, okay. How did you know? Oh, okay. So, guys, here's what happened. When I post my screencast to YouTube, I don't even monitor them once I post them. I just hit post and go away from the page and never look at it again, just assuming these videos have been posting. And then I had a couple students come to me and say, your screencasts are missing. And I'm like, I have no idea why. So I went on YouTube to figure out why they were missing, and I actually have a catalog of all of my videos. And there's this big red sign across the top of my YouTube page saying that my account has been disabled because of copyright violations. And I'm like, I'm the one doing the teaching. I'm pretty sure that I own the rights to post this material. So then I had to scroll through all my videos and find the ones that had been flagged. And back in October and early November of last year, I had 2 videos that were flagged for copyright violations. You ready for this? Both AP videos. So one of these videos, I show my AP students a video that another teacher made, and it's really simple. It's an Erlenmeyer flask, and the teacher's got the video camera on the Erlenmeyer flask. He takes a cotton ball, dips it in alcohol, lights it on fire, puts it in the flask, and puts a peeled, hard-boiled egg on top of the flask. The physics behind what happens is really cool because the flame heats up the air expands, and you can watch the egg jiggle as the air goes out. Then finally the flame goes out and the egg gets sucked into the Erlenmeyer flask because that warm gas contracts as it cools and it pulls in the egg. It's great to teach about pressures and things like that. I'm going to show you the same video after sage testing. Well, guys, it turns out that the teacher that did the video had the chicken dance song, flagged me for copyright because I don't own the rights to the chicken dance song. Seriously. Then, a couple weeks later, I was showing my AP students another video, which is this weird, ethereal, really crazy animation about how enzymes act on biological molecules to break them apart. And it's set in outer space, and there's like these animations of these blobs that come together and rip the molecules apart. And it's really weird, but it does actually teach about how this process works. But the way the guys did the video is really wacky. So every year what I do, just to kind of drive home the point that this is kind of ridiculous, is I play Enya in the background just because Enya is kind of weird and new agey and it sort of fits, right? Just to sort of go, yeah, this is weird. Got flagged for that one too. 30 seconds of Enya video in the background as my students are watching this video, and my account got flagged and shut down. So the long and the short of it is this: if you watch screencasts not by linking to them through my webpage, but by going directly to my YouTube channel, that doesn't work anymore because my YouTube channel is gone, okay? So you can still get to my screencasts just straight through my calendar, but guys, understand that to work around what YouTube did to me, I just opened up a new account and now I post all of these videos on a new account with a new username. But it works, but just understand that if you subscribe to my channel, that doesn't work anymore. You got the idea? So, oh, but by the way, YouTube did say that I could challenge these copyright issues, and if I want to challenge them, it comes up with a list of 5 bases upon which I want to challenge this, and I have to click the one that I think gives me the right to actually post these videos, and if I pick wrong, they actually disable my entire Google account, including my Gmail address, my Google Plus account, everything just goes away. That sounds pretty fair, right? Yeah. Welcome. Yeah, it's kind of nutty. Anyway, you guys ready to go? You good? Sorry. I just recorded all of that. Should I start over? Nah, that's all right. We'll just let people listen to it. because probably I won't be able to post this anyway because I just broke copyright talking about Enya because I don't own the rights to talk about her. Okay, so anyway, guys, here we go. This is what we're doing today. We are going to take the information that you learned last time as you were doing that lab, and we are going to draw a finer point to it and help you really understand what's up with acids and bases. Now, guys, here's the deal. Little disclaimer. The material that we are going to cover in one day, we cover in AP in 7 weeks. 7 weeks. So guys, here's what's going to happen. As we're going over this material, there's a very real chance that you're going to have intelligent questions. Please ask them. But guys, understand that we are doing a very high flyover, some very detailed material. So guys, you've got to allow me the freedom based upon your questions to say, you know what guys, that's a brilliant question, but it's way beyond the scope of what we need to talk about in this class. Either come back and take AP next year, or I'll talk with you about it outside of class. Fair enough? Okay, so guys, here's what we're going to do today. Don't write this down. Guys, we are going to actually accomplish these things today. First thing we're going to do is we're going to talk about what is an acid and what is a base. Do you remember what we said last time in class? What does an acid do? We talked about it before the lab. What do acids do? Give away hydrogens. What do bases do? Give away OHs. What happens when they come together? Water. Good. Okay. But guys, that's actually only one of the 2 ways of thinking about acids and bases. So we're going to introduce you to another way of thinking about acids and bases as well. Then when we're done with that, we're going to talk about what do they do when they react and what do they form when they react. And then finally, guys, we're going to talk about how do we measure the strength of acids and bases. And you already know the answer because we did a lab on it. How do we measure the strength of acids and bases? pH. And so we're going to do a deeper dive on pH, and that'll be our day. You ready to go? Here we go. So guys, first of all, what is an acid and a base? Well guys, there's 2 definitions for acids and bases, and they're named after the people that suggested them. So as we get into this though, the first thing that we need to do is we need to talk about what are examples of acids and what are examples of bases. Guys, don't try to write this down, but if we're going to talk about acids and bases and the 2 definitions named after the people that suggested them, we should at least have a concept of what are acids and what are bases. Practical examples. So here we go. So guys, battery acid. You know there's acid in your car batteries, right? Does anybody know the kind of acid that's in your car battery? Don't say battery acid. Someone said it. Yeah, you know, because you work on cars. Yeah. So guys, the acid that is in your battery is actually H2SO4, which is sulfuric acid. So what are other examples of things that are acids? Well, guys, did you know your stomach is a big bag full of acid? Did you guys know that? What's the acid inside your stomach? Hydrochloric acid, the same acid that you used in the lab last time. Guys, your stomach actually has these little cells that actually excrete hydrochloric acid into your gut, and that's part of what breaks down your food. So you may have known that. How about this one? Long distance runners and cyclists run into this all the time. Just a second. So guys, you understand maybe that you have an aerobic and an anaerobic metabolic pathway. And when you're exercising under your anaerobic threshold, then guys, your body deals with the metabolism process in one way. But if you get over your anaerobic threshold, all of a sudden your muscles are forced to go through a different anabolic pathway, and guys, you start dumping this acid into your muscles. It is lactic acid, and it hurts like crazy. So if you've ever felt your legs start to burn, not cramp's a whole different thing, but if you feel your muscles start to burn when you're running or cycling or whatever you're doing, that is actually lactic acid being dumped into your muscles. Guys, this is lactic acid, C3H6O3. And then guys, another example of an acid that you run into on almost a daily basis, you know about citric fruits, right? Lemons and grapefruits and oranges and all of those. And all of those have a tart taste because of the acid that's in them, which is what? Citric acid, which is actually C6H8O7. Got the idea? Okay, so here's the question, guys. What do all acids have in common? hydrogen, right? And doesn't that fit with what we talked about in the lab? In order to be an acid, you've got to give away hydrogen, and sure enough, hydrogen, 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 they all contain hydrogen, which allows them to be an acid. Now guys, don't get this misconception. Not everything that contains hydrogen is an acid, but in order to be an acid, you've got to contain hydrogen. You okay? Okay, so guys, what about bases? This is a little harder, isn't it? We talk a lot, not a lot, but I think we understand a lot more about acids than we do bases. Could you guys give me any examples of a substance that's a base? Milk is acidic, and actually so are potatoes. Do you guys know that milk is an acid? Yeah, so actually, and I'll show you in a minute, the pH of milk is about 6.5. It's actually an acid. Go ahead. Yeah, guys, did you know that? All soaps are bases. Any cleaning product except for bleach and the stuff then that takes the hard water stains off, except for those two cleaners, every soap and cleaner out there is a base. All soaps are bases. Any others? Yeah. Baking soda. Oh, good, because that's what we used in lab. Baking soda is a base. Do you notice how it's a little harder to come up with stuff? Let me give you some examples. So getting back to what you said, guys, all soaps and cleaners are bases. A really strong example of that is oven cleaner. Guys, oven cleaner is actually sodium hydroxide in an aerosol can. The same stuff that you used in lab last time, sodium hydroxide is actually a base. Another example of a base, which you probably would have come up with eventually, Rolaids. Rolaids is an antacid. Why do we take antacids? In order to neutralize the acid that's in our stomachs. So guys, does anybody know the base that's in Rolaids? It's actually aluminum hydroxide. It is a hydroxide salt. This one's aluminum. But guys, notice, what do all of these bases contain? OH, which makes them a base, right? Okay, now this is where this is going to get weird. So guys, other things that are bases. Ammonia. Ammonia cleaner is NH3. See the problem? Where's the hydroxide? Guys, this is where we need to expand our understanding of bases, and we'll do it in a minute. Because there's one type of base that does contain hydroxide. There's another type of base that is definitely a base, but it doesn't contain hydroxide. What you mentioned, Sydney, is another great example, baking soda. Baking soda is NaHCO3. It doesn't contain hydroxide, but it is a base. Another example is chalk. The stuff you write on the sidewalks with is also a base. It's calcium carbonate. So again, guys, it doesn't contain OH, but it is a base. So you get the idea? So here's what we're going to do. The first thing we're going to do is we're going to talk about all of these. The things that fit nicely into our understanding about acids and bases. And then we're going to have another conversation about what's going on that allows these to also be bases. So here we go. The first definition, and this is where you want to start taking notes. The first definition of acids and bases. This is named after a guy named Arrhenius. He was a chemist in the mid-1800s. You guys, actually, I'm going to edit this really quickly. So, as I throw this, I'm going to change this up just a little bit. There's an additional thing that I put in here that I'm going to pull out because it's going to actually work better. So guys, it goes like this. Here's what Arrhenius said an acid is. Arrhenius said that an acid is simply a substance that releases hydrogen ion. But didn't we already say that? That acids are substances that release hydrogens. Now all we're doing is adding to it the idea that they release hydrogen ion, and we'll talk more about that in a minute. But acids release hydrogen ions. What do bases do? You already know this. What do they release? Hydroxides, right? So acids release hydrogens, bases release hydroxides. And again, guys, I think you understand this. What happens then when an acid reacts with the base? The hydrogen and the hydroxide hook up, and what do you get? Water, right? So you want to write this down. That then leads us to the general reaction for an acid-base reaction, and it goes like this. An acid reacts with a base, and it forms salt and water. Now guys, be careful. Salt is not just NaCl, right? What are salts? Positive and negative ions bonded together, right? Anytime you have a positive ion and a negative ion bonded together ionically, that is a salt. That's going to be something you need to know for this SAGE test, guys. That's something good to keep in mind. So let me give you an example. Oh, go ahead. Good on you. That was my next question, but let me show you an example because you're absolutely right. Guys, check this out. So, and you're going to want to maybe include this in your notes. So guys, HNO3 is an acid, lithium hydroxide is a base. Well, that's really cool you picked up on that. So guys, this is then what's going to happen. The hydrogen will hook up with the hydroxide and it will make water, and then the nitrate and the lithium will hook up and those will make lithium nitrate. So Will actually got it without seeing it. Guys, all of these reactions are double displacement reactions where you end up with a salt forming from half of the reaction and then water forming from the other half of the reaction. That's neat you saw that. Nice work. Check this out. This is one of my nudge gifts. It is a cell phone holder. All right, you guys okay with that? So here's where we are. We understand that acids give away hydrogens, we understand bases give away OHs, and when the H and the OH get together, it makes water. But guys, notice that this requires a base that contains hydroxide. So we have not yet talked about the whole story because, guys, if we come back to this slide, we have not accounted for these. They are definitely bases, but they don't contain hydroxide. That means we need a broader definition for bases that allows us to include these guys. So here's our other definition. The other definition is named after two chemists, one from Sweden and one from Norway, I think. Their names are Bronsted and Lowry. Oh yeah, yeah, only because you need to know the definitions of them. So if I said to you, what does Bronsted-Lowry say an acid is? You would need to know that Bronsted and Lowry say that an acid is a proton donor. Now guys, you ready for a deep thought? See if you can wrap your head around this. The Bronsted-Lowry and Arrhenius, remember we just learned Arrhenius? The Bronsted-Lowry and Arrhenius definition of acids are the same. Can anybody connect those dots? Well, H isn't a proton. Yeah. Guys, this is the deal. Follow this in your head with me. Arrhenius said that an acid gives away what? Hydrogen ions, positive ions. Bronsted-Lowry says that acids give away protons. Guys, check this out. This is a hydrogen atom, right? Hydrogen is 1 proton, 0 neutrons, and 1 electron. But what do we have to do to make this hydrogen atom into an ion with a +1 charge? What do we take away? The electron. And when we take away the electron, we are left with a hydrogen ion, a proton. So guys, a proton is a hydrogen ion. So the Bronsted-Lowry and Arrhenius definitions for acids are exactly the same. Arrhenius called them hydrogen ions, Bronsted-Lowry called them protons, but in either case they're the same. So where does the difference come? Guys, the difference, as you would expect, is with bases. Bronsted-Lowry said that bases are proton acceptors. They don't have to contain hydroxide. All they have to do is accept protons. So now, guys, we've got a whole new way to think about acids and bases. Acids give away protons, bases take them in. So when we look at, and keep going in your notes, when we look at the general reaction for a Bronsted-Lowry acid-base reaction, the acid will give away a proton, a hydrogen ion. Where does it go? It goes to the base. So the acid gives away the proton and the base takes it in. So guys, what that does then is it creates something that we call conjugates. Have you guys all heard of the word conjugate? Do they still, if you've taken like Spanish or French, do they still talk about conjugating verbs? Guys, the word conjugate simply means to turn into something new. So, when we talk about this reaction, we have an acid that gives away hydrogen and a base that takes in hydrogens. And when that happens, we create a new acid and a new base, and we call them the conjugates. So guys, this is big deal number one. This is something that you've got to be able to do as a result of today, and this is going to be a big part of the test that you're going to take in April. You've got to be able to identify which is the acid, which is the base, which is the conjugate acid, and which is the conjugate base. So let me define these for you, and then I'll show you what you're going to have to be able to do. So first of all, conjugate acid. You want to get this in your notes as well. The conjugate acid is the thing that's formed when the base gains a proton. So the base picks up a proton. Now the base has got an extra proton, which means it can then give it away if it wants to. But now the thing that was once the base, because it has an extra proton, can now give away the proton, which magically makes it an acid. So the idea is this. You take a base, you add a proton, it becomes the conjugate acid. But guys, notice what happens to the charge. The conjugate base, the base, when it turns into the conjugate acid, its charge goes up. Its charge goes up because the proton that the base picked up is positive. So if you can see it there, that's fine. But if not, you may want to make note to yourself that the charge of the conjugate acid is one step higher than the base because of the proton that it picked up. And guys, I understand this is like, whoa, what is going on here? I promise you'll see this. Once you get the definitions down and we start playing with these, you'll do great. I promise. If I'm wrong, you can have my nudge cell phone holder. Gosh, the more I think about this, the more that I just feel horrible for that woman. That was one of the most awkward experiences in my life. It was not good. You guys all caught up? Okay, so conjugate acid. Then guys, the other side of this is the conjugate base. So what do bases do? They take in protons. So what is the conjugate base? Well guys, the idea here is that if you take an acid and remove a proton, it becomes the conjugate base. The idea is that when the acid loses the proton, it now has the ability to take in a proton, making it a base. So the conjugate base is formed when an acid loses a proton. So we could write it like this. Take the acid, take away a proton, and that becomes the conjugate base. But again, guys, notice what happens to the charge. The charge of the conjugate base goes down because the acid lost a proton, meaning, and because the proton's positive, the conjugate base's charge goes down by 1. So now you're really confused. You're like, good stinking night, what does all this mean? Guys, again, the thing that you've got to be able to do is identify acids and bases and conjugates. And here's what we're going to do. We're going to do 3 of these. I'm going to give you some examples. Along the way, there's a couple other little things you're going to learn, a couple terms, and then after those 3 examples, I've got another set of 3 examples we can look at. If you want to do them, great. If you find that you guys are comfortable with this and you're just ready to move on, that's fine too. So, you guys caught up with me? Y'all good? Can I go or is it too fast? Y'all good? Good. All right. So guys, you want to write down these 3 examples so you have a reference. So here's a reaction. Looks like this. H2SO4 plus water yields H3O plus and HSO4 minus. So guys, this is one of the things that you're going to see in homework. And one of the big things that you're going to see on the test, I will give you a bunch of balanced equations, and there will be lines underneath it where you will write down which one's the acid, which one's the base, which one's the conjugate acid, which one's the conjugate base. So guys, let's review. What do acids do? You okay, Marcus? Wells, can you help him with that? Yeah, thanks. Okay, so what do acids do, guys? Give away hydrogens. What do bases do? Take them in. So watch. Here's what you need to do to be successful with this. Go to the very first substance on the board, on the paper, whatever, and take away a hydrogen, okay? If it loses a hydrogen, what does that make it? An acid. So take away a hydrogen from the first thing that you run into, and then look for what's left over there. So if you take away a hydrogen from this, you're left with HSO4. Is there any HSO4 over there? Yeah, it's right there. So that tells you that that is what happens. H2SO4 does lose a hydrogen and become HSO4. So what does that make this? An acid. So you write it down underneath. Now guys, one thing to notice. The charge of H2SO4 is 0. There is no charge. Why is the charge of HSO4 minus 1? Lost a proton. That's what we're talking about with charge changes. Okay, so with that said then, guys, once you found the acid, the rest of this is easy. Because if this is the acid, what does that have to be? The base, right? Now to do the conjugates. Guys, let me show you how to do... Oh, go ahead. It is a base. And an acid. It's both. So let's talk about it really quick. What is it that's causing water to be a base right here? We added an acid. But what if we were to add a base? Then the water would be the acid. And guys, this is interesting. How do we know which substances are acids and which substances are bases? It's all based on water. If a substance can give hydrogen to water, it's an acid. If a substance can take hydrogen from water, it's a base. That's where we get the definition of acids and bases, is it's based, on water. So because water is both an acid and a base because it's HOH. It's cool you saw that, David. Yeah, okay. So guys, let me show you how to do the conjugates and never mess this up. To figure out the conjugates, go to the acid, take away the hydrogen, and what is left is the conjugate other guy. So if this is the acid, this is the conjugate base. It's the opposite. And then guys, once you know the conjugate base, what does H3O plus have to be? Conjugate acid. That's all there is to this. So guys, let me give you another example and see if you can do this on your own. It goes like this. CH3COOH. Remember when you had to write that in the Lewis dot structure test? It's the C double bond OOH thing. Plus water yields H3O and CH3COO minus. Guys, find the acid, find the base, find the conjugates. And guys, by the way, as I'm just looking down here, your tests are graded. Please don't let me send you out of here today without returning those to you. I know I'll forget. But you'll have time to work on your homework today. Actually, quite a bit of time. So we'll be good. Just remind me then. Did you get them? You're still writing. So guys, let's take a look at it. Again, if you follow these steps, you'll always get these right. So go to the first substance, take away a hydrogen, and then ask yourself, is there any of what's left over there? So if we take away a hydrogen, is there any of this over there? Yeah, it's right there. So what does that make this? The acid. So if that's the acid, again, what does that make water? The base. And then in order to do the conjugates, go to this, go to the acid, take away the hydrogen. What's left is the Conjugate base, and then the other one's got to be the conjugate acid. Yeah. Ugh, that is a great question. And the answer is no. Did you hear the question? Will the conjugate acid always be positive? Here's why the answer is no. If the base has a negative charge, then this would be neutral. So if the base was -1, then the conjugate acid would be 0. So it will always be higher, but if this starts negative, then this could be 0. If this started at +1, this would be +2. So it'll always be 1 higher. That's a great question. So guys, you get the idea? You good? Okay. Now in your notes, I need to teach you another term really quickly, and then we'll do one more example. Guys, scratch this into your notes. Hydronium ion. You guys are about to understand something pretty weird about acids. You ready? Hydrochloric acid, the acid that we used in lab. We have used that stuff a lot in lab. And what do I always tell you about hydrochloric acid? Don't get it on you because it will burn you. Now guys, here's the thing. If you get hydrochloric acid, HCl, on your skin and it starts to burn you, you are not being burned by HCl. Here's what's going on. Guys, turn your attention to the board. Let's do this. You guys now know what this stuff is, right? What is this acid? Sulfuric acid. Where do we find this? In batteries. We would never think about drinking sulfuric acid, right? But guys, what about this? What is this acid? This is vinegar. You put this on your salad and you don't think twice about scarfing it down. So guys, what's the difference? What is the difference between sulfuric acid and vinegar? Let's talk about it. Guys, the first thing that you need to understand is this. Substances are only acidic or basic if they're in water. In order for a substance to function as an acid or a base, it has to be in water. So guys, here's our water. Now think about this. What does this acid, sulfuric acid, do to water? Well, the sulfuric acid gives water a hydrogen, and the water turns into H3O. But guys, look at what vinegar does. Vinegar gives a hydrogen to water, and it turns into H3O. So guys, this H3O is actually called hydronium ion. So guys, the bottom line is this. All acids make hydronium ion. So if you spill hydrochloric acid on your arm, that is actually HCl dissolved in water. And what the HCl does is it gives hydrogens to the water and it forms hydronium ion. So if you put hydrochloric acid on your arm or sulfuric acid on your arm and it's burning you, it's actually not the HCl that's burning you, it's the hydronium ion that the acid formed in water. So we actually don't get acid burns, we get hydronium ion burns. So guys, then the question is this. Then why is it we can eat or drink vinegar if it does the same thing and makes hydronium ion? What's the difference? And guys, the difference is this. The amount of hydronium ion that's formed. Sulfuric acid and hydrochloric acid and the very dangerous acids make pant loads of hydronium ion, very high concentrations of hydronium ion, and that's what makes these acids dangerous. Guys, the acids that we don't think of as being dangerous also make hydronium ion. They just don't make as much, and as a result, they're not as corrosive. Get the idea? But all acids make hydronium ion because acids have to be in water. You guys sold on that? Okay, so let's wrap it up then. So the idea is this. Hydronium ion is always formed when an acid goes into water, and the stronger the acid is, the more hydronium ion it will make. By the way, how do we measure how much hydronium ion they make? pH. We'll talk about it in a minute. Okay, you guys good? Okay, just a little side thought as we're talking about conjugates. So guys, let me give you one more trial one, and then we'll see how we're doing. do this one. And guys, if the first two were easy for you, do this one. This one's a little trickier. Did you get it? You okay? Too soon? So guys, let's give this a try. What do? We go to the very first thing, and what do? Take away a hydrogen. And we take away a hydrogen from NH3, and we get NH2. Is there any NH2 over here? No. So guys, if there isn't any NH2 over there, we know that this is not the hydrogen loser. So what about a hydrogen gainer? Go to this first one and add a hydrogen to it, and NH3 becomes NH4. Is there NH4? Yeah. So what does that tell us about NH3? Does it lose or gain hydrogens? Gains them, which makes this the base. So now, guys, the same thing works. If this is the base, what does that make water? An acid. Now, how do we find the conjugates? To find the conjugates, go to the acid, take away the hydrogen. The thing that's left is what? The conjugate base, and that's the conjugate acid. Yep. Yeah, absolutely, yeah. So if this one failed, you could have just gone to this one, taken away the hydrogen, go, oh, look, there it is, and then you know it's the acid. Absolutely, Nick, yeah, for sure. You guys okay with acids and bases and conjugates? Is that okay? So let me ask you another question then. And guys, we've already sort of played with this, and Tyson, it was cool, actually, was the first to say it. Guys, which is water? Is it an acid or a base? And Tyson quickly said, it's both. And again, we talked about the idea that water will be a base when it's mixed with an acid, and water will be an acid when it's mixed with the base. So water is perfectly an acid and a base. But guys, you've got to understand, water is not the only substance that can be an acid or a base. And there's a name for it. It's called amphoteric. Guys, amphoteric refers to a substance that can act as an acid or a base depending on the other guy. And water is not the only substance that's amphoteric. There are dozens of them. It's interesting. Being a chemist, life can get weird sometimes. Hot tubs. I have absolutely no idea how somebody maintains their hot tub without a background in chemistry. My hot tub, any hot tub, is this little boiling, bubbling, warm chemistry experiment. But guys, it's interesting because most of the substances that you put in a hot tub in order to keep the pH and the chlorine and everything balanced, most of those things are amphoteric, in that they can be an acid or a base depending upon what's going on inside your hot tub. It's kind of cool. I think we should teach a class on the chemistry of hot tubs. And then I could buy a hot tub for the school. What do you think? Could be good. And we could come to school in swimsuits, which you wouldn't want to see. Okay. You guys good? Y'all caught up with me? Okay. So guys, you be the judge. You need to understand what amphoteric means. You need to understand what hydronium ion is. But guys, this is the big deal in red and blue. You've got to be able to identify acids and bases and conjugates. So this is what it's going to look like in the homework. This is what it's going to look like on the test. Do we want to go over these? Do what? No, we've got one really quick thing to do. Yeah, no, we just got one more thing. Guys, are you okay with acids, bases, and conjugates? Okay. Then guys, if you're good, last thing we need to talk about. I got to click through this. There's no other way to do it. Here we go. Last thing we need to talk about then is this. Guys, we now need to talk about the strengths of acids and bases and how we measure it. So guys, let's see if you figured this out. What do all acids do when they go into water? What do they make? You learned the name. What do all acids make in water? Hydronium ion. So why is it you would never drink battery acid, but you would drink vinegar? What's the difference? The amount of hydronium ion. Now guys, make this connection. How do we measure the amounts of stuff in water? What units do we use? Molarities. So guys, the idea is this. Sulfuric acid creates a very high molarity of hydronium ion. Vinegar creates a lower molarity of hydronium ion. But guys, when we talk about these molarities, we actually don't use the term molarity, we use the term pH. And we'll talk about the connection in a minute, but first of all, let's talk about fundamentally, and you probably never, guys, what does pH stand for? What does the H stand for? Hydrogen. What does the P stand for? It's not percent. It's actually a mathematical term that apparently they don't use anymore on the other side of third floor hallway. But guys, P actually mathematically means logarithm. Now here's the thing. You already know about logarithms because you did the last lab. You understand that logarithms simply change by powers of 10. That's all a logarithm is. So now that we're over this, guys, let's talk about what pH is. You want this in your notes. pH is a measure of the strength of an acid, but it focuses on the formation of hydronium ion. So it is really this. We understand that acids go into water to make hydronium ion, so pH is actually a measure of hydronium ion concentration. We're about 7 minutes away from done, guys. Just so you know. So what is pH? Bottom line, it's a measure of hydronium ion concentration. But guys, again, what are our units for concentration? Molarity. So when we talk about the concentration or the strength of an acid, why don't we just talk about its molarity? Why do we talk about pH? Well, guys, we're about to answer that question. Please don't write anything down on the screen beneath here. You ready to go? So guys, here's the question that's on the table. If we measure the strength of an acid based upon its hydronium ion concentration, then why do we use pH instead of molarity? Well guys, this is the answer. Even really kick-butt acids don't really make a whole lot of hydronium. So even sulfuric acid inside a battery that would kill you if you drank it doesn't really make that much hydronium. So the idea, guys, is that because the concentrations of hydronium are really small, they're very small decimal values, it's actually easier to just put these numbers in scientific notation. But here's the problem. Even after we put these numbers in scientific notation, they're still kind of cumbersome. And that's where pH kicks in. Check this out. So guys, this is an acid. Its hydronium ion concentration is 0.001 molar. If you drank this, you would die. But look at the hydronium ion concentration. It's not very great, right? This number is a pain in the butt to write down. So how do we make it easier? What do we do with this number to make it easier to write down? Put it in scientific notation. But guys, that is actually still not a whole lot easier. So this is where pH comes in, and pH takes a number like this and turns it into this. All of these things are the same. 0.001 molar is 1 times 10 to the negative third molar, but that is also pH of 3. Guys, where did the 3 come from? Right there. That's all that pH is. Remember, pH is a logarithmic scale. What does logarithmic mean? powers of 10. What are these exponents? Powers of 10. So all a pH is, guys, is this number right here that is the concentration of hydronium ion written in scientific notation. Do you now understand pH? I'll bet you do. Watch. So guys, here we go. Let this soak in for a second. So what we've got here is a pH scale. Up here are the bases, down here are the acids. Notice down here, Wells, milk is actually 6.4. It's actually fairly acidic. The reason that they have you drink it if your stomach is upset isn't because it neutralizes the acid, it's because all the fats coat your stomach and keep it from being gurgly. But guys, check this out. Down here, we have pH. Up here, we have hydronium ion concentration. So guys, check this out. What if we look at something with a pH of 2, like stomach acid? So guys, if the pH is 2, what is the hydronium ion concentration? We'll follow the circle. The hydronium ion concentration is 10 to the negative second. But what is that as a decimal? That's 0.01 molar. That's fairly concentrated. Now guys, let's go up the pH scale. What if we go up to pH 6? Is that more or less acidic than pH 2? Less acidic. So guys, now we're talking about milk. What is the hydronium ion concentration of milk? 10 to the negative 6th. But guys, that as a decimal is this. Do you now see why it's less acidic? It's a much smaller decimal. Now guys, let's go all the way down here to household ammonia, which has a pH of about 12. What is the hydronium ion concentration of that? 10 to the negative 12. But if you write that out as a decimal, guys, look at the hydronium ion concentration at that end. This is actually so small that there's more hydroxide than hydronium because the hydronium ion concentration is so little, and that's what makes it a base. So guys, the bottom line is this. Follow the arrows. What does pH do? It provides a link between hydronium ion concentration and pH. And the way that it does it is by bringing these two things together as an equation, and you want to write this down. So guys, this, and you've got to be able to solve this. So this is what pH is. pH, watch your eyes, I'm going to turn the lights back on. Guys, pH is the negative log of hydronium ion. But guys, you got to understand, these things that look like parentheses are not parentheses. They are brackets. And if you write parentheses, it's wrong because the brackets actually in chemistry mean molarity. So anytime you see brackets, and you're going to see this multiple times in this unit, guys, brackets mean molarity. So the last thing we need to do is this. I'm going to give you the hydronium ion concentration. You've got to solve for pH. I'll give you the pH and you solve for hydronium ion concentration. You got to be able to solve this in both directions. So guys, grab your calculators and we're going to try a couple. You ready to go? So guys, I would suggest to you, you don't need to write down the examples, but you do need to write down the solutions. Ready? Just read this with me before you touch your calculators. Question is this: what is the pH of a solution with a hydronium ion concentration of 1.0 times 10 to the negative 4th molar? What's the answer? You're done. It's 4, right? That's what pH is all about. But guys, what about this? What if the hydronium ion concentration is 3.6 times 10 to the negative 4th? Why is it no longer 4? Because this is no longer 1. So it should be close to 4, but it will not be exactly 4 because this is no longer 1. So how do we solve it? Write down the equation. You want examples of this, guys. This is the most missed section of the next test. you're going to find, guys, that you're going to get all the rest of this test right and you're going to miss these. Largely because you get sort of ahead of yourself and you don't give yourself the opportunity to write down the equations. So guys, pH is equal to the negative log of hydronium ion concentration. Then plug in the hydronium ion concentration. pH is equal to the negative log of this. Now guys, you know my opinion on TI calculators. I don't love them. They are horrible with orders of operation. That said, they are really good at this. If you know how to type this into your calculator, if you have a TI calculator, it'll solve it right every time. The trick is this. How do you enter this negative sign? It's not subtract. It's the negative sign that's down by the decimal key. So if you have a TI calculator, all you've got to do is type in negative log, and then you should know how to enter this number in your calculator, 3.6 EE negative 4. Just a second. And guys, once you get all that in your calculator, the answer to two significant digits is 3.4. Run it through your calculator. Make sure you get 3.4. If you don't get 3.4, we're not going to deal with that now. We're going to go on to the next problem type, put a little check mark by it so you know you still need to work on that, and we'll help you in a minute. Just a second. Go ahead, Nick. You okay? Go ahead. Two significant digits or two. Yep, you got it. And let me just tell you, Courtney, that's actually not really the rules for significant digits in logarithms. That's actually wrong. There's a different significant digit rule for logarithms, but I don't need to worry about teaching it to you. I'll teach it to you in AP next year. We're just going to go 2 and 2. Okay? Okay. So guys, again, if you didn't get 3.4, we'll help you later. Okay? Problem type number 2, and then we're done. Ready? Read the question with me. What is the hydronium ion concentration of a pH with a solution of pH 8? What's the answer? 1 times 10 to the negative. Done. It's this. But guys, here's the problem. What if this is not a whole number? What if it's 8.12? Well, now we need to solve it. So again, guys, write down the equation. This is the one you're going to get wrong. This one's a little harder. So guys, write down the equation and then plug in the pH. But then notice what I'm going to do. Just to make this easier, we're solving for hydronium ion concentration. I'm going to call it X. That's easier to write. Do you remember that day in algebra where you realized you had the power to replace anything you wanted to with X? It's kind of like being like a little demigod. Well, guys, I chose to replace this with X. Now here's the question. How do we solve this for X? What is the order of algebraic steps? First thing we do is divide by negative 1. So we move the negative to the other side. Now what do we have to do? Divide by log. How do you divide by log? Well, guys, dividing by log is the inverse log. And so on your calculators, if you found your log button, the inverse log most of the time will be the second function log or the shift log. It's actually the 10 to the x key. So in order to type this into your calculator, you will go second log of negative 8.12. Don't forget the negative. And guys, the answer that you should get is 7.59 times 10 to the negative 9th. If you're not getting that, please let me know. I would love to help. So guys, in front of you, you have your homework, and I'm going to be honest with you. It's hard. The questions on there are not just spoon-feeding back to me the stuff we did on the board. You're going to have to engage. You're going to have to think outside the box. Some of these questions are tough. Guys, the answers are posted online. Check your answers as you go. I'd love to help. We'll grade this on Monday, and then we'll go on from there. So guys, you've got your homework. The rest of the time is yours. You've got 20 minutes. The last 5 minutes of class will give you your test back. So if you need help with your calculators, let me know, and that'll do us.